Hello everyone! Today we are going to take a comprehensive look at filters. While I previously touched on filters when discussing search functionalities, that was just a brief overview. In this session, we will explore the filter context in much greater detail. When performing searches in Elasticsearch, you can utilize either query context or filter context. Let's start with the query context. Here you have the user's query. After that, the query context tries to answer this question: how well does this document match this query clause? After that, each document receives a score, with the highest scores indicating the most relevant documents. In contrast, the filter context focuses on the question: does this document match this query clause? Here, the result is binary. Either the document is relevant or it is not. You might wonder, why should we use the filter context instead of the query context? You use it because it performs binary matching. There is no need for score calculations. Filters execute faster than queries, and ultimately it consumes less CPU resources. If you are dealing with structured data, filters are the way to go. Structured data includes numerical fields, dates, Boolean values, or keyword fields. Filters handle these elements exceptionally well. So if you have structured data, please use filters. Let's look at some examples of how to effectively use filters. In our first example, we are retrieving documents from the phone's index. We are going to use the Boolean query because we are going to use compound queries. We have seen this in a previous video. Please check it out. Inside the filter query, we have two conditions. We are going to retrieve documents where the color of the phone is black and it comes from Samsung. You will notice that the filter allows for a list of conditions resembling an AND gate in logic. An AND gate is simple. You have two inputs. In our case, it's color and brand. Here is our gate. If both conditions are met, we will get yes. Otherwise, we will get no. Example number 2 follows a similar pattern, but this time we will use a date field to demonstrate how to handle this data type. Here we use the range filter and specify the date interval with greater than or equal to and less than or equal to parameters. And again, this works as an AND gate. So here you have status and publish date. Now let's introduce a new concept: post filters. Post filters are useful when you want to apply filters after aggregations have been computed. They don't impact aggregations, but they filter the search results. For instance, in a website with faceted navigation, post filters enable you to narrow down what users see without restricting their options. Here you can see we have the categories. For example, here you have experience level and job type. And in experience level, we have entry level, intermediate, expert. These are our filters. But the numbers you see between parentheses are aggregations. Let's examine a practical example. Suppose we are working with shirts. Initially, I'll filter for Gucci shirts. This will exclude other brands except Gucci. Next, I will compute some statistics using the aggregation parameter to determine the count of available colors. This is the first thing I will do. After that, I will filter the Gucci shirts by color, specifically red, and perform a filtering aggregation. When you have aggregation after filter, we call it filter aggregation. Here it will count how many models are both red and Gucci. Right now we have finished filtering the shirts and computing some statistics. This is the moment to apply a post filter to limit the results to only red Gucci shirts. So we have computed the aggregations, we have selected only Gucci shirts, but at the end, if you want to show just red Gucci shirts, we can do that with the help of post filter. Now let's go to VS Code to see how to implement this. Open notebook number 21. Please, if you don't have access to the notebooks, you will find a link in the description that will take you to my GitHub repository. Feel free to clone the repository to access the notebooks as well as the slides. First, connect to Elasticsearch. And here I have added a new JSON file which I called clothes. Let's open it to see what it contains. Here is the clothes dataset. You can see that we have 3 fields: brand, color, and model. Here we are creating a new index, and we use the bulk API to insert how many documents here we have. I think 100. Yes, we have 100 documents. We will insert them all into this index. Here it says false, which means that we were able to insert all documents. Great, let's continue. And to just verify, we can call the count method to get all documents that are inside the index. Now let's start with simple filters. Here you can see that we are using, again, the Boolean queries, and here we have just one condition. We want to get all documents where brand is equal to Adidas. Let's just verify. So I'll search for Adidas. Here you can see that we got 23 results. Let's run this, and here again, we get 23 documents back. If you don't specify size, this will return to you just 10. Let me remove this because that's the default value. But make sure to override it to get all documents at once. We can add another condition. So instead of getting all Adidas shirts, or clothes, we can narrow down the search to get just yellow Adidas clothes. So let me select this, and instead of blue, I'll change it to yellow. I'm getting 6 documents, and again, Elasticsearch gives me the same result. So this is how you use simple filters. But if you want to compute aggregations or even use filter aggregations and post filters, you need to look at this example. So here, again, we are working with the same index. First, we are filtering to get just Gucci clothes. So in total, we will get 30 results. After that, we will start computing aggregations. So here, again, make sure that when you use, because here we have text, you need to use keywords. Because by default, Elasticsearch will take the string and analyze it. So it will have 2 versions. It will have one version that will work for full text search, and the other one when you want to do, for example, matching. If you want to look for a specific value, then use keyword. So we are taking all those Gucci clothes and computing the colors. So here it will tell me how many red Gucci clothes we have, how many blue Gucci clothes we have, etc. After that, we are going to take just the red clothes. This is why we added another filter query. So here, instead of getting 30, we will filter that down to, let's see, to just 12 Gucci clothes. Now, inside the same object, we are going to compute another aggregations. We call this filtering aggregations because it comes after filtering. And here we are going to compute the count of model types. So we have 12 red Gucci clothes, but how many models do we have? This is what we are going to get after executing these aggregations. Finally, we can filter the clothes or the documents even further by using the post filter. Initially, we filtered the clothes by Gucci, so we will be getting 30 documents, but after that, we will select just the red Gucci clothes. So let me select this, and at the end, we should expect to get 12 documents. Let me run this, and as you can see, here we have 12 documents that we got back. But we can access the aggregations individually. The first one is the colors aggregations. Let's select this, and as I told you, first we selected just the Gucci clothes, but after that we wanted to know how many red Gucci clothes we have, how many blue ones, how many green ones, etc. And this is what we get with colors aggregation. You can see that we have 12 red Gucci clothes, we have 8 blue Gucci clothes, etc. After that, we filtered the clothes by color, red, and then we computed the count of models. So let's get that. And we call this, you can see that here it's color red. Okay, so it's color red. After that, it's models. And then we can access the buckets, which is basically the values. So color red aggregations will take the red Gucci clothes and then compute the number of models. I mean, for each one of the models that we have. So model 1, for instance, we have 3 of them. Model 14 and the other ones, we have just 1 of them. So this is how you use aggregations before using post filter. But at the end, because we used post filter, we selected just the red Gucci clothes. And this gives us 12 documents. And let's just verify. So I'll run this. And at the end, I will show you the length of hits. And this gives me 10. Why? Because I did not specify or I did not change the size of the query. After post filter, I'll just specify that size should be equal to, let's say, 20. Now let's compute the other values. And now we get 12 instead of 10. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like, subscribe to the channel, and see you next time.